Welcome to the Ultimate Factoring series. The goal of these videos is to help you learn everything you need to know about factoring. In my experience as a teacher, this is one topic that just gives students trouble sometimes, so I was seeking to find make a resource that would help any student who needed refreshing or just a fresh start with factoring. And so if you watch all these videos in order, you really should get the full picture of anything you could need to know about factoring. So this is the Ultimate Factoring series, lesson number 1, Greatest Common Factors. The first thing you should always consider when you're factoring is if there's anything that all the terms have in common. In other words, their greatest common factor. For example, here we have 2x minus 4. To factor, we want to see if there's anything that they both have in common that we can then factor out. Well, if you look at 2x and you look at 4, you notice that they are both divisible by 2. Since they're both divisible by 2, that means that 2 can be factored out. So factoring is one way to look at it is it's like division. So if I factor out a 2, I'm really saying, okay, 2x divided by 2 is just x, and then 4 divided by 2 is just 2. So 2x minus 4 can be factored to 2 times x minus 2. And that is our answer. If you ever want to check your answer, you can do so by multiplying it back out or distributing. So we'll do that on a few of these, not all of these. If we do 2 times x, that gives us 2x, and then 2 times negative 2 is negative 4. And you can see that gives us exactly what we had back. So we know then that we have factored correctly, and it's 2 times x minus 2. So our next example, 3x minus 21. Again, the goal is to find their greatest common factor. What's the biggest term, or number in this case, what's the biggest term that can be factored out of these terms? Well, if we look at 3x and 21, we notice that both of them are divisible by 3. That means we can factor out a 3. So again, factoring is basically like dividing. So we divide both of these by 3, that leaves us an x. We divide 21 by 3, that leaves us a 7. So our answer is 3x minus 7. Excuse me, 3 times x minus 7. We can correct or test that, check that by doing 3 times x, which is 3x, and 3 times negative 7, which is negative 21. So again, we get exactly the same thing back, which confirms that we did it correctly. Okay, next up we have 6x plus 39. The goal again is to find the greatest common factor. What is the biggest number that both of these have in common, or that can be factored out or divided evenly into? Okay, well if you think about 6, 39 is not divisible by 6, so that won't work. Well, 6 is also divisible by 2 and 3. Well, 39 is not even, so it's not divisible by 2, but it is divisible by 3. So both 6 and 39 are divisible by 3. So I pull a 3 out front. 6 divided by 3 leaves me with a 2x. 39 divided by 3 gives me 13. You can also make sure you're on the right track by just making sure there's nothing else that can be pulled out or that they have in common. 2x and 13 don't have anything else in common, so we know we're done. Next we have x squared plus x. Well, these have no coefficients except for the understood 1, so there's not going to be a number we pull out this time, but there is something they both have in common. Okay, both of these have an x value, excuse me, just an x. So we pull an x out front. We divide x squared by x, that gives us x. We divide x by x, and that leaves us 1. Make sure you include that 1. It's tempting a lot of times if you pull something out and it's the exact same thing to just make it disappear, but that's not allowed. The reason is you've got to, just if you notice when you check and you multiply it back out, x times x is x squared. If I had not included this 1, there would be nothing left for me to multiply to get the second term. So x times 1 is x, and that gives us exactly what we started with. So our factored form is x times x plus 1. Next we have 3x cubed minus 4x squared. Well, first of all, 3 and 4 don't have anything in common other than 1, and it doesn't help us at all to factor out a 1, so we're not going to bother with that. But the two terms do have x's in common. In fact, they both have at least x squared in them, because you want to pick out the greatest common factor, so the biggest term that they both have in common. Since they both have at least two x's to pull out, we can pull out x squared. That will leave us with 3x in the first term, because if you divide x cubed by x squared, it just leaves 1x. And it'll leave us with 4 in the second term, which, because x squared divided by x would just be 1, so it just leaves us 4 times 1, which is 4. So this would be our factored form. Okay, next example, we have 2x squared plus 2x. These have both a number and a variable in common. They both have a 2 that can be factored out. They also both have an x that can be factored out. So both terms have a 2 and an x. So I'm going to pull 2x out front. 2x squared divided by 2x will just leave x. And then 2x divided by 2x will just leave 1. So that is the correct answer, 2x times x plus 1. You can check that by multiplying it back out or distributing if you want. But I wanted to use this example to show you what happens if you don't notice everything that can be pulled out. Sometimes you may not immediately recognize what the greatest common factor is. So for example, let's say when I started this problem, instead of realizing that there was a 2 and an x in common, all I noticed was that there was a 2 in common. So then I might have done this. I might have said, okay, I pull a 2 out front, and that leaves me with x squared plus x. Well, then I have to look again and say, oh, wait a minute. X squared and x also have an x in common, so I need to also pull an x out front. And then that leads me to the same thing. So ideally, you'll notice the 2 and the x originally, and you'll pull them both out at once. But if you don't, that's okay. You just need to make sure, once you pull something out, you go back and look and check and see if there's anything else they have in common. Because you arrive at the same answer either way. Okay, so now we're getting a little more complicated. 7x squared y minus 14x to the fourth y cubed. So let's just start by thinking about the numbers. So first 7 and 14. Well, 7 and 14 have a 7 in common. So I'm going to pull out a 7. Next we're going to look at the x's. So x squared and x to the fourth. The simplest way to think about it is you can pull the smaller one out front. So I can pull x squared out front because I know both of them have at least x squared. X to the fourth has more than that in the second term, but the first term has x squared. So the simplest way to think about it is you can pull out the smallest one of the variables. So I can bring x squared out front, and then I need to think about the y's. So I have a y to the first in the first term and y cubed in the second term. Again, I'm allowed to factor out the smaller of the two, so I can factor out the y to the first. And then if you notice, I've factored out everything that the first term had, so that leaves me with just a 1. In the second term, I pulled a 7 out of the 14, leaving a 2. I pulled x squared out of x to the fourth, leaving x squared. And I pulled y out of y cubed, leaving y squared. And that would be my final answer. If it's helpful for you to go back and do the division, you certainly can. So let me show you what that would look like. we know we're going to be factoring by 7x squared y. So we're dividing both pieces by that. So the 7's completely cancel, the x squareds completely cancel, and the y's completely cancel, leaving us just 1. Okay, here we have 14 over 7, which gives us 2. Here we have x to the 4th over x squared. And remember, when you divide, you subtract the exponents. So you get 4 minus 2, which is just 2. So I have 2x squared. And then y cubed over y, that's really just y to the 3 minus 1. It's got to subtract the 3 and the 1. So that will also leave me with a y squared on top. So that's how I ended up with 2x squared, y squared. Okay, next example. 12a to the 4th b c cubed plus 30a squared b to the 5th c squared. Again, it's important to think about the biggest term that can be factored out. So the greatest common factor. So first, think about the coefficients. Think about the numbers. What's the biggest number that 12 and 30 have in common? Well, start with 12. That won't work. 30 is not divisible by 12. So then we can go a little smaller maybe. How about 6? 6 goes into 12, and 6 also goes in to 30. So I'm going to pull a 6 out front. Then I need to look at the a's. I have a to the 4th and a squared. And remember, on the previous example I said a simple way to think about it is you can pull out the smaller one. So a squared is the smaller one. That can be pulled out front. Then I have b and b to the 5th. B is the smaller one, so I'll pull out just b to the 1st. And then c cubed and c squared. So c squared is the smaller one, and I can pull it out front. Okay, so now I need to think about what's left. 12 divided by the 6 I pulled out is 2. A to the 4th divided by the a squared I pulled out is a squared. B divided by the b I pulled out is just 1, so there's no reason to rewrite that. And then c cubed divided by the c squared I pulled out would leave 1c, or c to the 1st. Okay, 30 divided by the 6 I pulled out will leave me a 5. A squared divided by the a squared I pulled out just leaves me 1, so I don't need to rewrite that. 5 times 1 is just 5. B to the 5th divided by the b I pulled out is b to the 4th. C squared divided by the c squared I pulled out is just 1, so there's no reason to write anything there. So that finishes our factoring. Like I said, it's always good to double check, look inside the parentheses, make sure there's nothing else they have in common that you need to pull out. And we can see here that there is not. 2 and 5 have nothing in common, and there's no variables that they have in common. Okay, now sometimes there may be more than 2 terms. You can do the greatest common factor no matter how many terms there are. So in this one, 2x cubed plus 2x squared plus 2x. We see that all 3 of them have a 2 and an x in common. But please note, we can only factor something out if all the pieces have them in common. If only 2 of them if only 2 of the 3 have something in common, we can't pull that out. It's only if every piece we have, whether that's 2 pieces, 3 pieces, 4 pieces, or 10 pieces, we can only pull out what every single term has. So every single term we see here, all 3 of them have a 2x in common. When I pull that out, that gives me an x squared first, plus x, plus 1. And that's the result when I divide each of those terms by 2x. Now we are going to learn how to factor trinomials, things with 3 pieces that are similar to what's inside the parentheses there. However, this one won't factor any farther, so we can leave it just like it is. Just a couple more examples. Here we see 4 times x plus 1 plus y times x plus 1. So this may look a little different, and it is a little bit different, but you're still looking at 2 terms. We have term number 1 and term number 2. Now the 4 and the y have nothing in common. but the x plus 1 and the x plus 1 obviously match. So I can pull x plus 1 out front because both pieces have 1. That leaves the first term with just 4, and that leaves the second term with just y. So when you pull something out, it can be a number, it can be a variable, it can even be a binomial. That just means something with two terms, like x plus 1. Last example. We have 2y times 3 minus 4x minus 9 times 3 minus 4x. Again, the 2y and the 9 have nothing in common. But as we look at this first term and this second term, they clearly have 3 minus 4x in common. So 3 minus 4x can come out front. That leaves the first term with 2y and the second term with a 9. And that would be our final answer. Thank you for watching. This is, again, just lesson number 1. Continue on to lesson number 2 when you're ready.